Okay, ladies and gentlemen, welcome to week 9, my recording. This is the second to last week, so I want to start with a quick pep talk, okay? The two most important times of any quarter, if you can guess them, okay, are the first 2 weeks and the last 2 weeks. And how do I know this? Because if you start and understand what you do in the first 2 weeks and get into it, you're far more likely to carry through. Whereas if you get way behind, there's students that just kind of give up. And then the last 2 weeks are where, there's exams due and you're trying to finish up the course. And so those are the two times of any quarter, just piece of advice for the rest of your life, that you should kind of go into what I call that, a little bit more intense mode where you're like 100% focused. Just knowing that those are the two, if I can really focus on those two time periods, the end of the quarter and the beginning of the quarter, that's when I'm going to get the biggest bang for my buck. I'm going to pass my class. I'm going to get a higher grade. But it's just important to be aware that we're in the last 2 weeks. So please don't quit on me. Finish the quarter, okay? And get your high school diploma because this is the last math class you needed, or whatever your situation is. Now you can start taking the next level of math. So, okay, this week's concepts, I don't think they're too complicated. Giving you the heads up though, next week, week 10, chapters 1.14 and 15, basically, of the text, those are a bit challenging. So there's a couple of formulas involved, and you'll get the formula, you'll write it down, you'll be able to use it on your homework, but just be aware, okay? All right, let's jump in here, and hopefully I can do all this in, I don't know, 30 minutes. We'll see. Um, so just as a reminder here, just as a review here, okay? When we're calculating, the interest of something, we're finding the percent of something, excuse me, okay? To find 2% of 62,000, okay? Um, if they ask you, what is 2% of 62,000? There's kind of two ways you can do this, okay? Most people use method one just because that's kind of the way they were taught. Method two is faster, okay? But you have to do a little bit of thinking up front, a little bit of thinking up front. So, but here's how most people would find out what 2% of a 62,000 is. They would turn that 2%, they would move the decimal point 2 places, uno, dos, okay, and get 0.02, which is where this came from, okay? I'm going to circle this just for your notes' sake and draw an arrow so you can kind of make sure you see how I got that. Then they multiply it by the number, and in this case, it's 1,240. That is 2%, okay? Um, Now, very often, if they just ask find 2%, that's what you would find. But if they ask you if you had a 2% increase of this amount, okay, or the price went up 2%, okay, which things are going up a lot. If you notice lately, a lot of percentage. So if they say the price went up 2%, you would figure out what 2% of the original price is, and then you would add that to this 140, you'd add that to the original price to find out the new price, okay? Just like when if you're trying to figure out how much to tip at a restaurant and it's, 10 or 15%, you'd figure out your total bill times 15%, get an answer. And then you have to add that amount, that percentage, okay, to the total bill to get the total. All right, so that's method number one, when we're calculating percent, and then adding it to a total. Now, method number two is to just think up front a little bit about, we got a 2% of, okay, so in a sense, that's 102%, okay? Now, why did I say that? Because if I had a 2% increase of this amount, 1.00 equals 100%. That's 100% of the 62,000, okay? So if I had 2% of that, if I had two more percentages to 1.00, I get 1.02, okay? So I can multiply that real fast times it and get kind of my answer of my total I'd have to pay with a 2% increase, on that $62,000 loan, or 2% interest rate, or whatever it is. Okay. So that method 2, you can do it in one step, but you got to convert it to the right percentage. Okay. Up front. All right. So that's just a little review. Okay. It'll help. Okay. Now, concept number 1 for chapter 12 is finding what's called the percent increase or decrease of something. Okay. So we've got, in this case, today milk cost $2.79 per gallon. If next year it will be 4% less, what will it cost? Okay, 4% less. So method number 1 was we'd figure out what 4% of 279 is. So 279 times 0.04, it's this amount. Okay, there's 11 cents. Okay, and then if the price of milk is less, okay, if it's less, we would subtract our 2.79, $2.79 minus 11 cents, and get $2.68. Okay, and that would be that is 4% less than the original price of 279. Now, method number 2 is the one-step method, where you go, okay, 4% less. 4% less than 100%. 4% less. 100, 99, 98, 97, 96. That's actually 96% of the original price. So if I take that percent and turn it into 0.96 times the price in one step, I now know the new cost. This 268 is 4% less. And by the way, if you kind of just want to notice, it's the same answer. Okay. So pick the method that works best for you. Okay. You got a calculator. It's going to go pretty quickly anyway, but I just wanted to kind of reintroduce this. All right. This is kind of the maybe the first or the second main concept of chapter 12. Okay. It's finding the percent change of something. So probably what you want to do is stop the recording, copy this down, and then press play again. Okay. All right. Having said that, here's the formula to find out the percent of change of something. And this is the formula you want to write down. Is you take the final value that they give you minus the original value, or the initial value, they'll say it in some textbooks. Okay. And we'll show you what this means in a minute. But the final value they give you minus the original value, you're going to get an answer. Okay, take that answer and divide it by the original or the initial value. That will give you a decimal. Okay, take that decimal and turn it into a percent, and that gives you the percent change. Okay, so now that you've written it down, let's look at an example and see if we can kind of talk it through here. So if a population increased from 40,000, here's my initial value here. I'll put initial above it. Initial. Okay, that's what it started with. Okay, or I in my other class tonight, I was just calling it the start value, because they actually got into this tonight. Okay, start value. All right, to 45,000. Find the percent change. Okay, if I take my initial value, so the final value is 45,000. Okay, so I'm going to draw an arrow here so you can kind of see where that came from. That's the final value. Okay, and I could just put down final next to this here, just so you see where it came from. And I'll circle that. It's all together. So final value minus the initial value, and I get 5,000. Okay, take that value. Okay, I'll just draw an arrow here, that amount, and divide it by our, what does it say? Our initial value. Okay. Okay. And so our initial value was 40,000 here. Here's the initial value, why did I say initial? Initial, TIAL. That's initial. Okay. So the $5,000 change divided by the 40,000 original value gives me, on my calculator, 0.0, or 0.125. To turn that into a decimal, move it 2 places, it's 12.5%, okay? So did we find the percent change? Yeah, we got an answer that's a percent. We found the percent change. That's how you calculate percent change, okay? Let's take a look at a couple more examples. Example 2, sales decreased. So I'm going to underline this, just reminding myself, okay, they're decreased from started. This is my initial, okay? And if I can actually write this correctly this time. This is my initial value to, and this is my final value. Find the percent change. They want to know the percent, okay? So I take my final value, 168,000, minus my initial value, 80,000, which is right here, okay? I get an answer. In this case, it's a negative because the 80,000 is more than 68. I get minus 12,000 units, okay? All right, I take that answer and divide it by my initial value, which is 80,000. I'm going to draw an arrow just to see where this 80 came from, okay? And I get negative 0.15, which is a negative 15%, okay? So it says sales decreased here, okay? It's decreased. There was a 15% decrease. That's why the negative here. That's the percent that it decreased. It went down 15%. Thus the minus here, okay? All right, let's take a look at, all right, so that is, going back here, that's everything, really, that's the main concept in chapter 12 is finding percent change. And keep in mind that percent change could be the percent something increased, that's the percent it changed, or it can be the percent it decreased, right? Because that's how much it changed still. It's still changed whether it's increase or decrease. If I go from 5 to 3, I decreased 2. If I go from 5 to 7, I increased 2. But it'd be the same percent in a sense, okay? All right, chapter 13, folks, is all about just a whole bunch of terms and then just like identifying them basically. So stop your recording, copy down what you see on the screen. And I'm going to pick it right back up here and start talking about these terms. Now, just so you know in your brain, like, okay, hey teacher, why are they also throwing a bunch of algebraic terms at us? Thinking about it kind of logically here, we're getting to the end of the quarter, right? And so we're getting ready to move into the next quarter. Oh, maybe that's why, because it's all came from the same textbook. The one class, 76 used the first half of the textbook, 86 used the second half of the textbook. So that's why at this point, towards the middle of the book, they started introducing these algebraic terms, just so you know, okay? All right. The first term is what's called a constant. And the best way to think of a constant is it's just a number, okay? If you think of a constant as a number, you're kind of going to be on the right track, okay? And so the definition of a constant is its value doesn't change, okay? Well, the value of 2 or negative 2 or 1/2 doesn't change in a sense, it's the same. So really numbers, okay, what we call integers, that's both positive and negative numbers. Those values don't change, okay? So they call that a constant. Constant means to stay the same, okay? Some people in poetry write about the constancy of the stars, and night after night, they're always there, twinkling and speaking their language. So, all right, the next concept is a variable, okay? And a variable is a letter, okay? So if you think about a variable as just a letter, when they give you X or A or Y, they call that a variable, okay? Now, variable, the word variable means, okay, in English, if something's kind of variable, it means it changes, okay? Notice the difference. Constant doesn't change, does not change, okay? A variable changes, okay, depending on what will solve the equation. And I want to pause here for a moment and because I know that for some of you, your anxiety level's going, wait a minute, this is where I started hating math, is when they started saying X's and Y's and it changed. You know, you're thinking, how am I supposed to figure out? Because A could mean this or it could mean that. All right. We'll try to simplify this and make it as simple as possible. But let me just give you an example over here real quick, just as a side note, okay? I'm going to choose just a brighter color here. If I say 2x, 2 times x equals 10, okay? 2 times what equals 5? I mean, I'm sorry, equals 10. Well, you can probably figure out 2 times 5 equals 10. So x equals 5, okay? X would equal 5 in this case. In this case, x equals 5, okay? All right. So this is the x is the variable, okay? However, if I said, using a different color here, green, 2x, that's a funny looking 2x equals 20. You could probably think in your head, what times 2 equals 20? 10. So x equals 10. Now, I want to pause here for a moment. Do you notice that in this case, x equaled 5? In this case, x equaled 10. Okay, that's why they're saying its value changes depending on what solves the equation. Okay, solves the equal sign, you know, that makes 2x equal 10. And so that's why it changed. And so I wanted you to kind of know that don't panic if they say, well, it changes. Well, we're just figuring out what solves the equation, okay? It changes because it depends on what this equal sign is. This case, it's 10. This case, it was, I'm sorry, this case, it was 20. In this case, it was 10. All right, back to our terms. Sorry, little side note there, okay? They have something in algebra they call a term, okay? And a term could be a constant, which we just learned could be a number, 5. That could be called a term. Or, notice the big or here, capitalized, okay? It could be a variable, okay? X or Y, it can be certain, can be considered a term. Or it could be the product of, product or quotient. Product means something times, like 2x, 2 times x, okay? Quotient means divide, just so you know here, okay? Just as a reminder. And this is times, okay? Product of or the quotient of them. So example, here's example, some terms, okay? 5, that's a constant, okay? If I draw a little arrow here, okay? It could be a variable like m. M is a variable. That's also considered a term, okay? They call it a term. 5m, that is the product of a constant and a variable. So see, when you squish two things next to each other, that means times each other, okay? So that's a term. 2x is a term, okay? And then, by the way, if I had 2 over x, that also could be considered a term because that is a quotient. That's a division, okay? So anyway, we've got constants, they're numbers, they don't change. Variables, they're just letters, okay? That's just another name for letters. And it would change depending on what would solve the equation. Terms are just x's, 5's, 5x's. It's another name for a term. And then we got this thing called an expression, okay? As an English teacher, I used to tell my math class, you remember how you learned there was a phrase and then there was a sentence? And a sentence is the complete thought, the whole thought. And so we call it a sentence because it has a subject and a verb and it expresses a complete idea, okay? But if I said, after school, if I say after school, the man was, and I stop, I've got kind of like a phrase, okay? Or just after school, I got a phrase. I don't have a complete sentence, okay? Well, that's kind of one analogy to what an expression is. It's very often half of an equation. You see here, see this 2x, that is an expression. And this over here is also is the other half of the equation, okay? So look at the definition. It's a mathematical phrase. Notice that's why I was saying phrase, like, okay, one term or more than one term separated by a plus or minus sign, okay? So it could be just one term on the other side of an equal sign, you know. This is an example of a term right here, this 10 here, okay, on the other side of an equal sign. So this is what we call an expression. It's half of the equation, okay? And then or, it could be, it says or here, so I'll circle or here, just reminding you what that means. It means or more than one term separated by plus or minus signs. So in the case of 1.3x, okay, that's a term. We already talked about that. That's a term here. It's a number, a constant times a variable. This is also a phrase. This is, I'm sorry, an expression. Okay, it's half the equation. So 90 is an expression. Okay, in the next example, 2x equals 5. 2x is the expression. It's half the sentence in a sense. 5 is an expression. It's the other half. Look in this example here. 3x plus 5 is 20. Okay, 3 times 5 is 15, plus 5 is 20. X must equal 5. All right, this is one half of the equation here. This is an expression, okay? I'm going to put EXP here to stand for expression. This over here, it could be a term or it could be something separated by a plus. This is also an expression, okay? So like you will see this on your next exam. They'll give you something like you're looking at right here. 3x plus 5 is 20. And they'll ask you identify the expressions, okay? Expressions. 3x plus 5 is one expression. 20 is the other expression. It's the other half of the equal sign, the equation, okay? So if you think of an expression as kind of that half of a, you have an equal sign in the middle. Now, sometimes they'll ask, identify the expression, and they'll just give you the half of it, 3x plus 5. Okay, well, that's an expression. Okay. All right, moving on to the next thing that this all builds up to is something called an equation. And this is really where we're talking about algebra really very often, okay? It's a statement that two expressions, you notice here, two expressions are equal, okay? And that's why we have the equal sign. That equal sign is very powerful in algebra. It sets a law. When you put that equal sign there, you mean, okay, whatever goes on this left half has to equal exactly whatever is happening on the right half. So the equal sign is actually more powerful than you realized, all right? So an example of an equation here is 2x plus 5 equals 15. This whole thing now is like, in English, it's like a complete sentence. It's got an expression, an equal sign, and then another expression. That's what we call an equation. So simplified equations are something where something equals something else. And it's a complete sentence in a sense, okay? So that is why we call it, it's a whole sentence, an equation. And by the way, if this will help you to remember this, I'll just choose some red here. You see in the word equation, it almost sounds like it spells out equal. It's got all the letters of equal except for one at the end. And thus the equal sign. When you have things on both sides of an equal sign, you've got an equation, okay? If that helps. All right, another term that you're going to see in your homework, okay, is factors. And you'll also be asked this on your next exam, I think, as well. And these are things that are multiplied, okay, terms that are multiplied, okay? And there's a reason why I'm hitting at this right now, and I'm going to show you why. If they ask you for all the factors of 6, I think some of you at this point could probably go, okay, well, 6 times 1 and 3 times 2. Those are all the factors, okay? If I draw an arrow at my factors here, of 6. However, now we jump into algebra here. What are the factors in this equation? Notice I said equation, not I didn't call it an expression or a term or a variable, but I said in this equation, what are the factors, okay? All right, what are the things, here's what you want to look at. What are the things in the whole equation that are multiplied times each other, okay? All right, well, there it is right there. There, I'm going to circle it. These two things are the only factors. They're the only things that are multiplied. Look at the definition, terms multiplied. So if they ask you on a test, what are the factors in this equation? You would say 2, comma, x, in a sense, 2 and x, okay? Now, I want to distinguish something here, okay? Some of you might be thinking, why did I just say 2x? Because 2x is actually got two different factors. It's got 2 and x. Okay, so it's not just one term, it's 2 and x. Make sure you get the difference between that, okay? It's everything that's multiplied, okay? Let's jump over here. If I kind of move myself out of the way, look over on the far right. You got 4y plus 2b equals 80. And if they ask you to identify all of the factors in that, what is that? Is it an expression, a term? Is it a variable? Is it a constant? No, it's an equation because it's got equal in it. It's got an equal sign, okay? Identify all the factors, okay? Hopefully you can look at that and go, oh, by the way, I'm sorry. I'm looking at this and going, this looks like 26. This is a B here. Sorry, the letter B. Okay, that's a B. I'll write a B above it. Okay, a little arrow here. It looked like 26. It really still looks like 26. Okay, all right, so that's 4y plus 2b. What are all the factors? 4, comma, y, comma, 2, comma, the letter B. That's a better B. Okay, those are all 4 factors. Make sense? Okay. Hopefully you're starting to see it's all the things multiplied times each other. All right, this is a concept that will be hit at again in your homework, where they'll throw in an exponent, okay? And we're gonna talk about exponents here in a moment, but let me just like 2 squared, okay? And I think we've hit this before. You know, if we had the numbers 2 squared, and they ask you, okay, what does that mean? Exponents, okay, just remembering these things called exponents are the little numbers above a number, okay? So 2 squared means 2 times 2. It's just 2 times, okay? 2, this technically would be called cubed, or 2 to the third, okay? This is the exponent, so it's 2 times 2 times 2, it's 3 times. 3 to the fourth, the exponent is this thing right here. That means 3 times 3 times 3 times 3, 4 times, okay? That's 3 to the fourth, okay? Just a little review, helping you with understanding of your homework here, which is gonna lead right into talking about polynomials, okay? So polynomials, and again, you're going, hey, this is another term. Yeah, we're getting to our last, I think, like 2 terms here, okay, guys? Poly means many, and nomials is like numbers or expressions. Is an expression, okay, it's an expression. We learned that that's like half, that's a phrase, that's like half of the equation, with one or more terms that are constants or products of variables. So like 2x products, okay, and constants. So variables and constants, that products of a variable and constants would be like 3y, okay? That is the product, that's multiplied. There's my constant and there's my variable. That is a product of them. And then the exponents must be whole numbers, okay? So for it to be considered a polynomial, and that's why I just talked about exponents, okay? And so what I mean by that is you actually can have, you can have exponents that are like fractions, okay? And so if you have exponents that are fractions, then the whole thing's considered not a polynomial. But if it has exponents that are whole numbers, regular numbers, then it could be part of a polynomial. So, all right, so what we have here on the screen is 3 different types of polynomials, expressions times or being products of variables and constants, okay? And this is kind of the key thing. You'll see this on your exam, okay? If you have just one term, like here, they call this a monomial. Mono means one, okay, or singular. So mono, I'm just going to draw this right over mono, which means 1. Okay. It's got one term. So if you've got one term, it's called a monomial. If bi means 2, okay. So biannual, something that blooms twice a year or something, or an event, it's 2 terms, okay? So 2x plus 5, you'll notice I have this term, and then I have it separated by plus 5, okay? So that's a polynomial, but what type of polynomial is it? It's a binomial. It's got 2 terms, okay? One term, mono, 2 terms bi, and then tri means 3, okay? Just so you know, that means 3. So a trinomial, this, by the way, is trinomial. That should be an O there, nomial. 3 terms. So 4x plus 3x plus 5, you've got term 1, term 2, and term 3. So you have 3 terms there. So we call that a trinomial, okay? A polynomial that just has 1 is mono, bi, and tri. Okay. Okay, we're almost done here. This will be a concept in your homework. It's things to the degree, okay? When I'm solving things to like what degree is it? They give you some terms and stuff, and they ask you like, to what degree is that? All right, so take a moment and just copy that down in your homework. And I'm gonna give you some examples of what I'm going to talking about here. So if this is, I just developed this kind of like a little chart here to help people understand, okay, how do you tell what degree? It's the highest exponent in a polynomial is the degree it's 2, okay? Highest exponent, and we looked at exponents, that little number, okay? So if I had the number 7, you'll notice there is no exponent. So if they ask you how many degrees, okay, how many degrees is 7? It's got no exponent, so it's just 0 degrees, okay? All right. If they ask you for 7x, okay, I've now got a variable here. We would call this to 1 degree, okay? Now you're probably thinking, okay, 7x squared, there's the 2 there. That's the exponent. That's the highest exponent in this term here. So that's 2 degrees. That kind of makes sense. But you might be going, well, where's the 1 up here? Here's why there's no 1, because you know that x to the 1 is just x times 1, right? So we don't actually write the 1 up there because it's just given. It's assumed that if it's 7x, it's really the 7x to the first, which means just 7x, okay? Just so you'll know. So if you have a variable, that's considered 1 degree, okay? If you have an exponent that's a 2 squared, that's the highest, that's the degree, it's 2 degrees. If it's to the third, it's 3 degrees. If it's to the fourth, it's 4 degrees. I think you kind of have the general idea, okay? All right, so I'm going to put some sample questions on the board. In fact, I'm just going to do them over here. We'll call this practice. Okay. All right. Okay. So if they ask you, if the expression is a polynomial, identify it as a monomial, binomial, or trinomial, or none of these, and identify its degree. So we're supposed to tell if it's a mono, bi, or tri, and what degree, okay? And if the expression is not a polynomial, then state this and give the reason why. So let's look at practice number 1 here, okay? If I had 5 minus 3y to the third, or squared, excuse me, squared, okay? All right, first of all, so I'm gonna write mono, bi, comma, or tri, okay? And you have to find the degree, okay? All right, so I'm looking at this. All right, is this polynomial? Is it a monomial, binomial, or tri? Well, hopefully you're looking and going, 2 terms here. That's it. It's a tri. I'm sorry, it's a bi, excuse me. Binomial. And to what degree is this? Well, by definition, it's the highest exponent. There's no exponent here. This has an exponent squared, so it's 2 degrees, okay? That's how I would identify that in my homework, okay? All right, EES. All right, let's look at number 2 here. If I got the equation 5n squared, n squared to 5, minus 9n plus 2. And I ask you, is that a polynomial, first of all? And is it, if it is it a monomial, binomial, or tri? We've got a term, and a term separated by minus and plus signs. This is a trinomial. And to what degree is it? Okay, what's the highest exponent? Okay, so that's a 2 there. Well, here's my degree. Okay, so it's 2 degrees. All right, let's look at another one, okay? All right, number 3 here. If I have this right here, 4, okay. Is that a monomial? First of all, is a polynomial, okay. Well, by definition, a polynomial can be just a term or adding terms together. Is it a monomial, binomial, tri? You're probably knowing that it's a monomial, okay. It's mono, okay. And is it, to what degree is it? It's 0 degrees. Why did I say 0? Because there's no exponent, okay. All right, let's look at maybe 1 or 2 more here. Let's see, if I have, let's see here, x to third minus, I'm sorry, plus x squared minus x minus uno, okay? All right. And they ask you, is that, okay, is that polynomial, is that a monomial, binomial, or trinomial? You would say, I got 1 term, 2 terms, 3 terms, and 4 terms. It's none of the above. It's not a mono, a bi, or a trinomial, okay? And then to what degree is it? What's the highest exponent? So it's 3 degrees, okay? All right, I wanted to kind of go over that to give you some examples to help you with your homework, okay? Hopefully that will be somewhat helpful, and I think that is it. So folks, if you have questions, be sure and shoot me an email. I do want to say that, let's see here, we are wrapping the quarter up here, so be sure and stick with me. Be sure and listen to or come to the live session next Monday night when we talk about some things with some formulas, chapter 14 and 15. As a reminder, during finals week, okay, which is week 11, okay, that's when you have to have turned in all of your WAMAP homework. You know, that's what you're doing. You're doing the book homework and the WAMAP homework every week, same exact chapters, okay? Second reminder I want to tell you for the second or third time is, do not do WAMAP chapter 15. It's actually 1.15. Don't do it. And the reason why is because one of my colleagues who on campus who created this wonderful WAMAP for the class, which is wonderful that he did this. In chapter 15, he got really kind of carried away with dice. Like if you roll dice twice, what is your percent chance of having, you know, all sixes, or I mean, 2 sixes both times or whatever. Anyway, it was just kind of cumbersome. So, all right, I hope that's helpful. Let me know if you have any questions.